Hello, welcome to another laboratory session. Today we are going to talk about the thyristors, the applications of thyristors. So at first, what is a thyristor? Let's see. Thyristor is a power semiconductor switch which is somewhat similar to a diode. This also conducts in only one direction as diode, and also apart from the characteristics of diode, the thyristor required a current pulse to initiate the conduction of the current. So that is the major difference in between a diode and a thyristor. Here in this slide you can see the symbol for the thyristor. Similar to the transistor, here we can see three terminals. In diode we have only two terminals now. In diode, anode and cathode. But in a thyristor, we have another terminal called gate other than anode and cathode. So in this practical, we are going to talk about some methods to initiate the conduction current of a thyristor. Some of the methods to generate the current pulse to initiate the conduction of the thyristor can be shown as you can see in this slide. To explain these methods, we are going to analyze 5 subtopics separately in this practical. In part A and B, we are going to analyze a DC switching circuits, whereas we are using a push button to generate the required current pulse to the thyristor in part A and generate the current pulse with the help of an overcurrent in part B. Further, in part C and D, we are turning to the AC switching, so opening and closing of the thyristor is controlled by a miniature switching in part C and by using a light source in part D. Eventually, we are going to do a comparison in between a mechanical switch and a thyristor switch with respect to their switching times. Here, let's see some of the applications related to a thyristor. These are the main objectives in this practical, as you can see now. So let's move into the power electronics laboratory. This is a real thyristor. You can see on the surface there are some letters printed on it. Those are the rating values. This is the thyristor trainer kit that we are using for the demonstration purposes. This is the ammeter, DC ammeter. You can see these notations. And this is our oscilloscope. There are 4 channels in this oscilloscope and the power supply. Let's move to the part A. Here you can see the actual circuit diagram. Then you have to connect the circuit as in this diagram. Then press the push button S3 and you have to notice the lamp is lit up as thyristor SR3 starts to conduct current because it was triggered when S3 presses. Now press the push button S4 and notice that the lamp turns off. Here in this part A, we are using a push button to initiate the current across the thyristor. For the sake of ease, we can consider these junction connections in order to implement our circuit on top of the trainer kit. You might think that why we use this junction table. That is because all the electrical and electronic devices are already inbuilt inside the trainer kit and only the necessary open terminals are coming out from the circuit, as you can see here on top of the trainer kit. And also most of the wiring were already completed inside in the trainer kit itself, and we have to connect few of the open terminals to complete the circuit. Likewise, we have to connect these terminals by using wires in order to get our actual circuit. Right, now we can connect our junction terminals by using these connecting wires on top of our trainer kit. Inside of this trainer kit, we have all the power electronic devices such as diodes, thyristors, resistors, potentiometers, transistors, each and everything is inbuilt under the top surface of this prototype board. Here on top of the thyristor trainer kit, you can only see the open terminals coming from those devices, which you can connect them in order to implement any circuit. As now we are connecting our part A circuit. Alright, now we have already connected all the wires in our circuit diagram. Now we have to connect our oscilloscope in order to get the measurements. As you can see now, we can connect the oscilloscope. Okay, now we can start the practical by pressing the push button S3 like this. Now the bulb is lit up, and by pressing S4, it turns off. Then we can take the observations by using the oscilloscope like this. So the observed graph can be shown as now you can see in this slide. Now you can pause the video and analyze these graphs. So let's move to the part B. Here you can see the actual circuit diagram of part B. You have to connect the circuit as you can see in the diagram. Then switch on the prototype kit, and then you have to set your current potentiometer RV1 to 0 position, which gives the maximum resistance. Then press the push button S3 and notice the lamp is lit up. Here you can see in the diagram, when you press the push button S3, thyristor SR3 triggers and current will start to conduct through SR3. Then gradually rotate the potentiometer in clockwise direction to increase current through the path which is wired parallel to the lamp. Series connection of RV1 and R4. Where RV1 is a potentiometer and R4 is a fixed resistor. Now you can observe at one instance the lamp switches off because high density of current starts to flow across RV1 and R4. As an important fact, it is not advised to leave the lamp lit for more than several minutes as the potentiometer RV1 can be heavily heated and might be damaged. Now you can see the corresponding table with the junction connections related to the part B. Here you can see the wiring diagram on top of the trainer kit. Okay, now let's move to a closer look of our implementation. Okay, now we are rotating our potentiometer from 0 position in clockwise direction in order to get a point where the bulb turns off. Okay, now we set our potentiometer in its initial position. Now let's move to the part C. Right, now you can see the actual circuit diagram related to the part C. You have to connect the circuit diagram as you can see now. Then switch on the prototype kit and then toggle the switch S2 to its closed state and notice that the lamp is lit up as SR1 and SR2 start to conduct the current. So what is SR1 and SR2? So here those are the thyristors. Now change the S2 switch's position back to its initial state and notice the lamp switches off as two thyristors stop conducting the current. Right. This is the table which we can have an idea of junction connections. So here are the junction connections on the trainer kit. Now you can see the practical demonstration which we have conducted in the laboratory. When the S2 switches off, the bulb turns off. Okay, so this is the graph we have taken by using the oscilloscope. Now it is time to pause the video and analyze this. Now let's move to the part D. Here you have to connect the circuit as shown in the diagram and switch on the main power supply and notice both the lamps L1 and L2 lit up where the L1 is the small lamp and L2 is the load lamp. Now you have to insert a barrier, a thick paper in between the lamp L1 and phototransistor. You can observe the load lamp turns off as the thyristors SR1 and SR2 turn off. That is because when the phototransistor was blocked by the paper, the transformers T3 and T4 turn off. Then remove the barrier and notice the load lamp lit up again. So this is the junction terminal connections as before. This is the wiring connections on top of the trainer kit. Let's move to the actual demonstration in the laboratory. Now you can see when we cover the phototransistor, the load lamp turns off. These are the observations from part D. Now you can pause the video and analyze this. Now let's move to the final part, part E. Here you have to connect the circuit as shown in this figure and then switch on the main supply. Then press push button S4 and notice the lamp is lit up as the coil RL1 energized and retain the switch at on position. Now switch off and again switch on the supply and notice that the lamp does not light up. Press S4 and notice that the lamp is lit up again. Here you can see the junction connections and the connection diagram on top of the trainer kit. Finally, this is the practical demonstration for the part E. Now you can pause the video and analyze these graphs. So here you can see the calculation parts that you have to do by using the observations which you have seen previously. Finally, the discussion part of the practical. According to what you have learned in this practical, please answer to these questions.